All right, everybody. I have here a can. It's an Arizona Arnold Palmer can. Look at that guy right there. And so I put a little bit of water in that, and then here I have this beaker of cold water next to it, and there's the Arnold Palmer. It's got water in it. It's on the Bunsen burner. The water inside's getting hot, which means the particles are moving faster and faster and faster because the temp's going up. And pretty soon it's going to boil. And then I'm gonna do something with this cold water, and then the can, and then you'll see. How about that? Let's pause. Okay, the water in the can's boiling. Here we go. I'm gonna shut the burner off. Here we go.
Whoa.
Now, the can got crushed. Clearly, the can got crushed.
Does it make more water?
Now, question. I hope you can tell. Did I crush this with my beaker tongs?
No.
No, I did not crush that with my beaker tongs. So why did it crush?
Because you dipped it in water.
What about pressure?
I don't know.
It went from hot to cold really fast.
What were the contents of the can when they were on the flame?
Boiling water.
Water.
It was water, Schulteis.
So you tell me there was no Arnold Palmer left in that period?
Yes, that's exactly what I'm saying.
I doubt that.
This can has been in here for years.
Whoa.
So no, there was no Arnold Palmer in it. I even put some water in it and then rinsed it out to make sure that there was nothing in it except some water.
Seems pretty sus.
So anyway, if we could get back to the actual conversation here, why did this happen? The contents were very hot. In fact, there was some boiling water in there, and then there was also some vapor inside there, yeah? Then I flipped it upside down so that it what? The water did what to the can?
Crushed it.
Left.
Touched
Pressure.
It sealed the can, folks. The open end was down in the water. I took it like this, I flipped it over, and I put it open end down, so the water now sealed the can. Also, the can did what?
Crushed.
Because, well, hold on, folks. You're getting ahead of yourselves. I put the can in the water. The water is cold. What happened to the can?
It went.
Smooshed.
What happens to a hot can when you put it in cold water?
It
It
smooshes.
sizzled.
It gets colder.
It gets cold,
Lost on
which
it.
means the stuff inside the can got cold. And what do you know happens to particles and therefore objects when they get cold?
They slow down.
Slow down.
They slow down, they need less space,
And they should.
and so they contract.
Oh.
What happened to the atmosphere? It pushed on the can to get into place inside the can where the stuff shrunk so quickly. It was rapid contraction. And in fact, some vapor in there condensed back into liquid. So you've got this whole can here that's full of like water vapor, and it quickly condenses back into liquid form. And what did we say about the density of water versus air?
Was.
About 1,000 times different in density, which means the vapor went from 1,000 times less dense to as dense as water. So all that vapor condensed down to like a couple little droplets, which means the whole inside of that can was like a vacuum, and the atmosphere crushed it from the outside trying to get in. So it's kind of a pressure thing. It's kind of an expansion contraction thing, because what was inside the can contracted rapidly because of the temperature drop. Does that make any sense? Now I've got another thing here that is a little flask here with some water in it. And I will get it heating up. And of course this thing's going to take a little bit, so I'll just pause you until I get that hot. How about that? All right, so we're boiling. Shut that sucker off right there. We're boiling. I'm going to close. Oh, you piece of junk. I'm going to close the container off. Ouch, that's hot. That is real hot. That is real hot. Now, I am putting this over here. We see that the balloon is kind of inflated. there's actually still a little bit of boiling going on. Now it just stopped. So now that the flask is sitting on a cold table, the particles are not, the boiling has stopped. The particles now sitting on a cold table, what's beginning to happen to the water particles? And therefore the particles of air in the flask.
Condensation.
They are what?
Condensation.
Well, they're what I heard someone say it. They're slowing down, folks. The particles in the flask are slowing down. They're slowing down, and that means that the space that they need to take up is what? The space that they need to take up is getting smaller because they're not moving as fast. So they need less space. So this balloon is now kind of deflated. Yeah? It was inflated, now it's deflated. So luckily I have a flexible lid on this flask. And here in a second, oh boy. Oh boy.
What?
Okay.
So, oh my. Oh boy. So now,
Whoa, I missed it.
dude. So now the balloon is literally inside the flask. If I put this thing in the cool water, oh, making a mess there too. Let's see if we can make a mess. So now I'm speeding up the cool down, correct? So now the particles are even moving slower and slower and slower and slower because I'm making them cool down real fast. And if you notice now, how much space is there between the balloon and where the outside of the flask is? Not nearly as much. That used to occupy that whole thing, the flask plus the balloon sticking up. All of that is now the size of just what the space is between the inside walls of the flask and the balloon in there itself. So that air really shrunk down small. And so how do I get this balloon out of there?
Heat it up.
Put it back on the burner, which is now going to do what to the particles of air in the flask?
It's going to melt the balloon. It's going to melt the balloon.
Oh my gosh. Those on the video, I'm sorry, that's not actually going to happen. Mr. Iser is here, of course.
It's going to melt the balloon.
It's not going to melt the balloon.
Let's
And
watch.
so,
I bet it does.
the particles in the flask now are beginning to
Melt the balloon.
heat up and
Pop the balloon.
heat up and,
Explode.
well, what do they do from heating up? They're moving faster! They're moving faster and they need more,
Space.
so they get further. And the balloon is going to be pushed out of the flask. So the air that's inside the flask right now, the particles are moving faster and faster and faster, need more space, get further and further apart, and they are again pushing the balloon out of the flask.
It's raining in there.
And again, if I set it aside, the same thing will happen that happened before. If I, however, leave it on there and allow the boiling to continue,
It'll explode.
then the more boiling that happens, the more what gets put into the air that's inside the flask. The more water vapor gets put in there, the more that boils. Which means the balloon could do what?
Explode.
It could blow up and blow up and blow up, and of course eventually it could explode, or at least just be pushed off of the lip of the flask.
How long does that
And
take?
so that, again,
Let's do it.
there's more gas in there now than there was before because some of it, again, has come from the water itself.
Why is it cooling?
As it cools down, though, some of that vapor is going to condense back into liquid, and you'll end up with just what air was in it in the beginning. And so again, as it cools off, what's in there is slowing down. The particles are slowing down, needing less space, beginning to contract again, to the point where the balloon will eventually get pushed back into the flask from the atmosphere out here. How about that? How about that? Now, one more thing. One last thing. Excuse you. I have this thing right here. Oh boy, hold on, I gotta try to pick this up.